error in any measurement, and a measurement of a value or quantity in an experiment always has error. We can never measure something to be exact. So error can either be random, which basically describes how there's random fluctuations in the data. It could be a little bit higher, it could be a little bit lower, and we'd see that with repeat measurements. Or it could be systematic, which is where you systematically get a shift in the measured value compared to the true value, consistently always in one direction. And these errors can be caused by different things. Start by talking about random error. So one thing might be the readability of the measuring instrument. So it might simply be that you're trying to measure something on a scale that's not really appropriate for what you're measuring, or that you can't estimate between divisions very well. And so that means that every time you go and make another measurement, it might be slightly different to what you had before. Or it could just be that your scale is a very long way away and it's difficult to estimate at that distance. Also, something that could affect or produce random error are variations in your surroundings. Perhaps if you were looking at the factors affecting a ball's flight through the air, if you had small wind gusts around, then that might affect your results and it would be random. Another thing is the observer and how the observer interacts with the measuring instruments and with the experimental apparatus. The observer is the one taking the observations. So if an observer came to, say, measure a height of something over and over again, there's going to be small variations because of, say, the angle the observer is looking at. It may not always be exactly the same angle, and so that might cause some random error. Of course, one of the best ways we can minimize random error is to take repeat readings. An individual measurement might have a large error, but if we take multiple measurements, they all will average out. And so you can adjust for that effect. You can minimize the effect of random error by taking repeated readings. And of course, we can address the points that I've made above by adjusting the surroundings, changing instruments, and observing in different ways. Just to note here, a small random error means your measurement or your reading is very precise. So random error has to do with precision. So now we move on to talking about systematic error and some of the things that cause systematic error. So remember, this is something that's systematically offset in one direction. The first thing could be something that's not calibrated properly. So a scale, if you bought a really cheap ruler and it wasn't made very well, and each of the divisions for millimetres were actually 1.5 millimetres apart, then your measurements would consistently be underestimated. So that would produce a systematic offset. If your scale has a zero reading, so if before you measured the mass of something you didn't tear, so press the little button that zeroes it on your weights on your scales, then your final results would be consistently offset from the true value. And again, the observer making those measurements, say consistently looking at a scale from a strange angle, these are all things that can affect or produce systematic error. We can minimize systematic error by independently calibrating instrumentation, which is not always possible, or perhaps using different instruments to measure the same thing. We can take note of and subtract where appropriate zero readings on things, or make sure things are zeroed, so measuring instruments like a set of scales are zeroed before you use them. And of course observing in a different way. For systematic error, unlike random error, it's a little more dangerous, sometimes really difficult to identify that you have a systematic error, and difficult to reduce. So these things can be difficult to demonstrate that they're there, particularly things like incorrect calibration. And it's nasty because systematic error is related to accuracy, which you know is a measure of how close the value is to the true value. So we could have things really reproducible. They have very small random error, they're very precise, but they're really offset because of the systematic error. So these are things you've got to really think about. Look at your data, look at your final results, and really question, how well do we know this? What are some of the sources of error that could affect our measurements?